What if the most profound breakthroughs in medicine weren't just born in a lab, but whispered by an algorithm? We might just be standing on the cusp of that reality. Well, that future is arriving faster than you might think. Google DeepMind, the folks known for mastering Go and protein folding, just announced a truly monumental step forward this week. Working hand-in-hand with researchers at Yale University, their latest biological artificial intelligence system, aptly named Cell-2 Sentence, Scale, or C2S, Scale for short, has done something remarkable. It generated a completely new hypothesis for cancer treatment. And here's the kicker. They've already experimentally confirmed it in living cells. Now, we're talking about a highly complex problem here, one of the toughest challenges in cancer immunotherapy. You see, tumors come in different flavors, if you will. Some are hot, meaning your immune system can actually recognize and fight them. Others are cold. They're essentially invisible to your body's natural defenses, like wearing an invisibility cloak against your own immune system. Making those cold tumors hot is a holy grail for scientists, opening the door for treatments to actually work. C2S, Scale, a massive 27 billion parameter model built on Google's open-source Gemma family, dove deep into this mystery. It didn't just crunch numbers. It started thinking like a scientist. The AI analyzed patient tumor data and then simulated the effects of over 4,000 different drug candidates. Its mission? To find a drug that could act like a spotlight, making those hidden tumor cells suddenly visible to the immune system, but only under specific biological conditions. And it found one. The model predicted that a specific compound called silmitasertib, which is a kinase CK2 inhibitor, would dramatically increase something called antigen presentation. Think of antigen presentation like a tumor cell waving a flag, saying, "Hey, I'm here. Attack me." The really fascinating part. The AI predicted this only happens when the immune system is already somewhat active. This wasn't just a random guess. It was a targeted, conditional prediction. What makes this so groundbreaking? Google emphasized that this wasn't just the AI regurgitating existing knowledge from scientific papers. This was a novel idea. While researchers knew CK2 played a role in many cell functions, no one had reported silmitasertib explicitly enhancing antigen presentation in this context. It wasn't just finding a needle in a haystack. It was designing a brand new needle altogether. To test this ingenious prediction, the researchers took human neuroendocrine cells, basically tumor cells, and treated them with both silmitasertib and a low dose of interferon. The results were astounding. Antigen presentation shot up by roughly 50%. Imagine those cold tumors suddenly becoming half again as bright to your immune system. It's like turning up the volume on a barely audible alarm, making it impossible to ignore. Google's CEO, Sundar Pichai, rightly called this a milestone for AI and science. And the DeepMind team believes this isn't just about this one discovery. It's a blueprint. It shows us that scaling up biological AI models doesn't just improve accuracy. It unlocks the ability to generate entirely new, testable hypotheses. This is the true promise of AI and science, discovering the unknown, pushing the boundaries of what we thought possible. Of course, it's crucial to remember that this is still just the first powerful step. This discovery needs rigorous peer review, and any therapeutic application will require years of preclinical and clinical trials. But the framework is now there. Yale teams are already diving deeper into the mechanisms, testing even more AI-generated predictions. So, while we stand at the very beginning of a long journey, consider this. An AI has not only found a new clue in the fight against cancer, but it's also shown us a new way to do science itself. This isn't just about faster drug discovery. It's about fundamentally changing how we approach biological mysteries. What other impossible questions could these powerful digital minds help us unravel? We'd love to hear your thoughts on this incredible development. Share your insights, and make sure to subscribe so you don't miss our next deep dive into the future of tech.